Hi, my name is Bhumanand Barik and welcome to my YouTube channel. In logistic regression, we have already seen how binary classification happens. Binary classification means when there are two options in label, in output column there are two options like A and B, yes or no. Like there are two options, so we can use binary classification method using logistic regression. So suppose there is a data point. In that data point, the output feature is here. This is output feature or the dependent feature. These are the independent features. Suppose age, and this is salary. So these are different features, and this output feature is containing suppose three labels. Three label means here suppose A and B and C, like this there are three labels, or we can say like there are other labels like old, young and kid. Like this there are three labels. So we have to classify this output feature into three levels. So how logistic regression does this? Let's see. So in this multi-class classification, suppose this is the graph. Earlier there were two options, two levels, which used to be linearly classified. Now there are three levels. So how this three level happens? Something like this. This is one level, this is one more level, this is another level. So like this there are three levels present which we need to classify. So here the formula which is applied is OVR formula. OVR stands for one versus rest. One versus rest. So we have to consider one level, and we have to keep like that rest of the labels. So suppose this particular red marks is considered one level. So like this we have to classify. These two labels will be kept aside, and which will be compared with this red like cross and red label. Once it is done, again we have to classify again we have to classify by keeping one more level like this. This green part will be kept aside, and it will be compared with these two options, two labels. So this is this one versus these two one. Earlier it happened like this one versus these two one. Like this one more classification will happen like this. These blue lines, this blue cross will be kept aside, which will be compared with red and green. Green. Like this. So mathematically how does it happen, that we need to see. What happens? Suppose this is the data set. In this data set, this is output column, and these are some features: F1, F2, F3, F4. Like this, these are features. So based on these features, for one set of data set, we found one output. For remaining features, we found one more output. For remaining features, for one more row, we found one more feature. But when we are considering these output features, again these output feature will be divided into three parts, because we are having three levels. So how does it happen? Let's see. Here O1, O2, O3. So like this it happened, like 1 minus 1 minus 1, again it minus 1 plus 1 minus 1, again minus 1 minus 1 plus 1. Like this the output is taken. Again plus 1 minus 1 minus 1, minus 1 plus 1 minus 1, and minus 1 minus 1 plus 1. Like this, for 3 options, 3 output is taken considering probability. So probability will be checked for these 3 outputs. This only one output is taken, but this one output is further divided into 3 parts, considering which one has to be taken. Whether the first option is giving positive result, and the second there are 2 remaining options, 2 remaining labels are giving negative result, or the first option itself is giving negative result, the second one is giving positive result, and the third one is giving negative again, or the first or second both are giving negative and the third one is giving positive. Like this, for all the output, such kind of 3 results are taken. Now the probability is considered between that. Let's say here, for the first one, for O1, the model name is M1 model. For O2, the model name is M2 model. And for output 3, the model name is M3 model. So from these 3 model, ultimately it is found logistic regression will arrange a value between 0 to 1. 0 to 1. So for the M1, suppose it found a value like 0.20, and for this one it found like 0.30, and for this one it found like 0.50. So if you add, it is something like 1. The addition of these 3 options for M1 model, for M2 model, for M3 model will be 1. But separately, if you see, this is having probability of 0.20, this is having probability of 0.3, and this is having probability of 0.5. So the model which is giving highest probability, that has to be considered for the output. So here what we can say, like that, if the data set is there and output 1, output 2, output 3, O1, O2, O3 is given. So this O3, or for O3 output, like M3 model, if the probability is highest, then this probability will be considered. For the second line, if the probability of this O2 model is highest, then this probability will be considered. Like that, the highest probability model will be taken into consideration. So how does it happen? If you see in the graph, 1 versus rest done, and this is one model. Suppose this 1 versus rest is done, and this is one model, M1. Again for this one, again one more model, M2, and again for this one more model, M3. So as we have seen, the probability of M3 is higher. So in this scenario, this probability is considered. So when logistic regression is actually applied on multi-class environment, that time a parameter has to be set. That parameter name is multi-class, like this. The parameter is multi-class parameter. And that parameter has to be OVR. If OVR is set in Python, when that scikit-learn Python is implemented, so during that time OVR has to be set, and if OVR is set, 1 versus rest formula will be applied in the algorithm. For every new test data, the number of output present, suppose in the output the number of labels present, that number of probability will be generated, and we have to consider the highest probability. And this, in this way, multi-class regression happens in logistic regression. So hope you have understood the concept of multi-class classification in logistic regression. Please share the video and subscribe to my channel. Thanks a lot.